These are the steps you can use to multiply radicals. So you can multiply coefficients, which are numbers out in front of the square root. You can multiply the radicands together, which are numbers inside the square root, and then you would want to simplify the radical if possible. So for our first example, the number out in front would be -3, so that's a coefficient. Out here we technically have a 1. So I could multiply those two together. When I do that, I would get -3. Square root of 8 and square root of 2 are both in a radical, so those two can be multiplied together to get square root of 16. Then I want to check if I can simplify my radical, and I can because square root of 16 is actually just 4. So I have -3 times 4, which is -12. Similar on the next example, I can multiply any numbers that are out in front. So -4 times 2 is -8. I can multiply any numbers inside the square root, so 14 times 8, which is 112. Then I want to simplify the radical. So square root of 112 can be written as square root of 16 times square root of 7. The square root of 16 is actually 4. -8 times 4 is -32. The next few examples include variables, but it's the exact same process. So you can multiply any numbers outside the square root. So 4 times 1 is 4. You can multiply any numbers inside the square root. So 6 times 6 is 36. N to the second times n is n to the third. Then I can rewrite this. So remember, when we have variables, we need them to be written as an even number times an odd number. So it would be n squared times n. So the square root of 36 is 6. The square root of n squared, since it's even, we divide, so it would just be n. And then I'd be left with square root of n. 4 times 6 is 24. For the next example, again, multiply the numbers out in front. So 7 times -2 is -14. You can multiply the numbers inside the radical. So 12 times 6 is 72. You can then multiply your variables. So a to the third times a is a to the fourth. Then I want to simplify the radical. So square root of 72 can be rewritten as 36 times 2. And since a to the fourth is already even, we can just leave it as is. The square root of 36 is 6. A to the fourth is even, so we just divide the exponent by 2 and it comes out of the radical. And we have square root of 2 left over. -14 times 6 is -84. And then we have a squared, square root of 2. A few more examples, and it's just important on these to remember your order of operations, which is PEMDAS. And mainly when we do this, we need to remember that we would multiply and divide first and add and subtract second. So I want to multiply anything I can multiply first. So in this first example, I can multiply 10 times 3, and I get 30. And then I can multiply 2 times 10, and I get 20. And then I'll just rewrite the minus square root, 6 square root of 5. I can simplify square root of 20. It would be square root of 4 times square root of 5. Square root of 4 is 2. 30 times 2 is 60. And after I've simplified the multiplication portion as much as possible, if the radicals match, you can just do the addition or subtraction. So I have 60 minus 6, so I would have 54 square root of 5. The process is really similar for the next example. So again, we have to remember order of operations, so I want to start with any multiplication first. So I'm just going to carry down this 7x cubed square root of 6. I can multiply the two radicals together, so 12 times 2 is 24. X to the second times x to the fourth is x to the sixth. I would want to rewrite and simplify this, so 24 is really 4 times 6. And x to the sixth is already written as even, so I can just leave that alone. Square root of 4 is 2. X to the sixth is even, so I divide the exponent by 2, so I have x to the third, and I'm left with a square root of 6. Now that all of my multiplication is done, I can just do my addition. So I have 7x to the third plus 2x to the third, which is 9x to the third, square root of 6. When doing multiplication, you may also have to do the distributive property. So I have square root of 6 times 3. Since they're not both in a radical, I would just write them next to each other, so 3 square root of 6. Then I have square root of 6 times square root of 8. Since those are both in a radical, I would actually multiply them together to get square root of 48. Then I can simplify square root of 48, which would be 16 times 3. Square root of 16 is 4. And since these radicals do not match, I can't simplify any further, so this would just be my final answer. For the next example, I do almost the exact same thing, except I'm going to have to distribute twice. So I'm going to start with the 4. So 4 times 2 is 8. 4 times negative square root of 3 is just negative 4 square root of 3. They can't be combined because they're not both in a radical. For the second term, 2 times square root of 3 is 2 square root of 3. Again, they're not both in a radical, so they can't be combined. Square root of 3 times negative square root of 3 is negative square root of 9. Then I want to go back through and simplify anything that can be simplified. So 8 cannot be simplified. Negative 4 square root of 3 can't be simplified. 2 square root of 3 can't be simplified. But square root of 9 is just 3. Then I want to combine any like terms I can. So I have 8 minus 3, which is 5. Since these square roots match, I can combine those. So I have negative 4 plus 2, which is negative 2 square root of 3. To do division of radicals, you want to break apart the radicands and write it as 2 separate square roots. You look for a perfect square and simplify if possible. You want to simplify by dividing and reducing radicands if possible. And then you simplify the result along with any coefficients, which again mean numbers out in front of the square roots. So here's our first example. So first we want to write this as 2 separate square roots. So we want to write it as square root of 8 over square root of 32. Next, we want to look if the radicands will simplify. So if this was just written as a fraction, 8 over 32, you would probably tell me that you can divide both of those by 8. 8 divided by 8 is 1. 32 divided by 8 is 4. So this fraction really reduces to 1/4. If there are square roots, the same thing can be done. Square root of 1 is just 1. Square root of 4 is 2. So this really simplifies to be 1/2. For example number 2, same thing. It's already written as 2 separate square roots, so we're okay there. Next, I would want to check if I can divide 96 and 3 to simplify. I can divide both by 3. 96 divided by 3 is square root of 32. Square root of 3 divided by 3 is square root of 1. The square root of 1 is 1, so really my fraction would be written like this, which I can actually just write as square root of 32. Then I would want to see if square root of 32 simplifies. Square root of 32 can be written as square root of 16 times square root of 2. Square root of 16 is 4. So this simplifies to 4 square root of 2. On my next example, I want to check if I can simplify the fraction out in front. 4/3 is already as simplified as it can be. Then I want to look for a number I can divide both 15 and 27 by, and that number would be 3. So 4/3, 15 divided by 3 would get me 5, 27 divided by 3 would get me 9. Then I'm going to look if my radicals can simplify, and square root of 9 is actually just 3. So now in my denominator, I have 3 times 3. And 3 times 3 is just 9. Last time I would want to check to make sure that my fraction can't simplify now, and it can't, so this is my final answer. On the last example, if I check the fraction out in front, 3/15 is the same as 1/5. I can divide 84 and 7 by 7. 84 divided by 7 is 12. 7 divided by 7 is 1. And we know the square root of 1 is just 1, so I actually don't even need to write this. I also don't need to include this 1 out in front, so rewritten, I really just have square root of 12 over 5. Square root of 12 can be written as square root of 4 times square root of 3. The square root of 4 is 2. Since 2/5 can't simplify further, and neither can square root of 3, this is our final answer.